we're going to express the repeating decimal 0.232323 and so on. This also has the following notation. We can write 0.23, 0.23, and then the last one, we put a line above it. It means it repeats forever. We want to express this repeating decimal as a ratio of two integers, that is, as a rational number. Now, a repeating decimal is a geometric series, so we can write this repeating decimal as 0.23 plus 0. Now, instead of the first 23, we put two zeros, and then another 23, plus, now we put 4 zeros, and 23, and finally we can put 6 zeros, and 23, and then this pattern is repeated every time we go to the next term. We replace the previous 23 with 2 zeros, and then follow them up with 23. Now, a geometric series always has a common ratio. If we take any two terms, one that follows the other, like this, and like this, and like this. So any two terms except the first. And we take the subsequent term and divide it by the previous term. We can't do that with the first term because there's nothing that precedes it. But we can take 0.0023 and divide it by 0.23. We get 0.01, which is 1 over 100. And also we take, let's say, 0.00000023 and divided by the term before it, which is 0.4023. We also get 1 over 100. So this is a geometric series with common ratio of 1 over 100. So we can rewrite it in the following way: 0.23 plus 0.23 times the common ratio 1 over 100. That will give us the next term. 0.23 times 1 over 100 squared plus 0.23, 1 divided by 100 cubed, and so on. And using summation notation, the sigma notation for series, we can write this as sigma n equals 0 to infinity 0.23 times the common ratio 1 over 100 raised to the nth power. You can easily check that that in fact is the series. When n is 0, 1 over 100 to the 0 is 1, so that gives us just 0.23. When n equals to 1, we get 0.23 times 1 over 100, and so on. Now, in standard form, a geometric series looks like this: 0 to infinity, a times the ratio to the n, and when r is strictly between -1 and 1, this geometric series is going to converge. So it converges to a divided by 1 minus r. Remember, that's only true if r is between -1 and 1. And, well, in our case, for this series, a equals 0.23 and r equals to 1 over 100. That, of course, is less than 1 and greater than -1. So the series converges to 0.23, that's a, divided by 1 minus 1 over 100. So that's 23 divided by 100 divided by 99 divided by 100, which is 23 divided by 99. And that's our answer, the repeating decimal, 0.232323. So the repeating decimal that we started with is equal to rational number 23 over 99. Now you can check this by plugging it into your calculator, and you will see that when you put in 23 over 99, the answer your calculator gives you is precisely the repeating decimal, 0.232323. Now we can also solve this problem without using sigma notation, because the geometric series we start with is the repeating decimal, and we can write it as 0.23 plus 0.0023 plus 0.000023, and so on. We know that this is a geometric series because all repeated decimals are geometric series, and so very important that we understand the common ratio R is 0.01, and this R is 0.01 in any common ratio. If you take any two terms like that and divide, you'll get 0.01. Now this 0.23 is the first term of our series, and once we are sure we're working with a geometric series and R is between -1 and 1, the common ratio, we can go directly to the sum, which is first term divided by 1 minus the common ratio. And so in this case, that will be, just like before, 0.23 divided by 1 minus 0.01. So this is 0.23 divided by 0.99, and that comes out to be 23/99. Now we can take any repeating decimal that has two digits repeating, for example 0.595959, and so on, and similarly show that this will be equivalent to a rational number 59 divided by 99. And similarly 0.818181, so on, is equivalent to 81 divided by 99. Now some of these we can factor further, like 81 divided by 99 we can divide by 9, so this is equivalent to 9 divided by 11. Some of them we can't factor further, and some of them we can. For more videos, visit www.mathprepvideos.com.